On Linux, at least with AMD and Intel GPUs, most people are using open source GPU drivers. A big part of this stack is the Mesa project. When it comes to NVIDIA cards, however, not so much when we're dealing with older cards. It's kind of your only option. When you're dealing with newer cards, some of the newer projects are actually relatively okay options. For cards in the middle, however, your mileage definitely may vary there. There are open projects, but most people are using the proprietary drivers with the open kernel module. Now, I wouldn't normally talk about Windows on this channel unless I'm making fun of Windows, right? Totally honest there, that is something I'll do. However, I will make an exception in this case. In this case, it is something directly related to Linux and also something being funded by Valve, so I thought, hey, let us take a look. Cracking Windows open, porting RADV to Win32. RADV is the open source Mesa Vulkan driver for AMD GPUs. Over the years, it has become a cornerstone of the Linux graphics stack. It has now effectively become the de facto Vulkan driver for AMD hardware on Linux. No one even considers the fact that there actually was a separate proprietary version that it did exist at one point. You could use it if for some reason you wanted to, but even AMD themselves, they work on the RADV driver. They work in Mesa because that's now the main driver. Like, yeah, they could push a proprietary driver and try to, like, really focus on that, but they've realized that, like, it makes more sense to just collaborate with people that you're not paying. Will NVIDIA eventually catch on? Who knows? Maybe, maybe not. It is a mystery. Right now, they're sort of like playing footsie here and there. They hired the Novo developer a few years back to keep working on Novo, and it's like a little bits and pieces here, but nothing like AMD is doing. On Windows, however, AMD users are still served only by the proprietary driver, but don't panic. We have a solution, porting RADV to Windows, bringing the same open source Vulkan implementation that has proven itself on Linux to them. It's such an improbable proposition that we might actually get there faster than light. Not going to be that quick, but eventually we'll get there. Now you might be thinking, what is even the point here, right? Like, there is an AMD driver on Windows. Why would you want to port this version over to Windows as well? Like, what benefit is there going to be in doing that besides it just being kind of cool? Why would this be something that Valve goes out of their way to go and fund Collabora to do? Well, whilst it's not directly supported, did you know that some Windows gamers make use of DXVK? They take the tool we use on Linux to convert DirectX calls into Vulkan calls, just so we can play DirectX games, and they use it on Windows. Even though they support DirectX, that's DirectX is part of Windows, Vulkan also works. The reason they do this, I don't know the technical reason why it works, but in certain games, under certain conditions, doing this will actually get you more performance. Now, it very much depends on the game, very much depends on the implementation, but it has been directly, measurably observed. My best guess, and this is purely just a guess, Vulkan has lower level access to the hardware, so there's less sort of extra cruft that has to deal with. Maybe that's the case, maybe it's just the fact that sometimes the version of DirectX lines up weirdly with Vulkan, where Vulkan does better. I don't actually know. You need to do like a deep dive on those individual games. Some games, it does just do worse or around about the same, and it's literally just a waste of time. But when it does better, it does do better. Over on the PC Gaming Wiki, there is a page on how to set this up if this is something you are interested in. Do note, it is not directly supported, so you might end up breaking something. Whilst this might seem like a tangent, there is a point I'm trying to make here. My point is that doing something like this, taking tech that is supposed to be used on Linux, bringing it over to Windows and having some sort of benefit, isn't entirely unprecedented. An open source Vulkan driver on Windows opens up a number of possibilities, a shared codebase across platforms. This is a really big one. So let's say there is some problem that happens where, I don't know, there's just a bug with Vulkan rendering, for example. And that isn't a bug exclusive to Linux, it's just a problem with the implementation in RADV. But Windows has a lot more people on it. Windows has a lot more gamers. So if you can get RADV into a situation where gamers on Windows are using it, suddenly problems which traditionally would have only been found when a Linux user eventually found it are now being seen by a much larger user base. Easier debugging and experimentation, faster turnaround on fixes. Again, if a problem can be found faster, it is faster to go and fix it. And a path for the community, e.g. game developers, to report problems or contribute improvements that benefit everyone, regardless of operating system. And when we're in a world where gaming on Linux isn't done through native games, it is done through Proton, right? It's done by taking Windows games and then translating those calls into calls that work on Linux. The more shared tech you have, the easier it is for game developers who want to support Linux, but don't feel comfortable, don't have the expertise, the equipment to actually go and properly build a Linux version. The more similar you can make that gaming environment to what you have on the Windows side, the easier that is. Now, for some people, that's a problem because, traditionally there's been the whole no tucks, no bucks, where if a game isn't available natively on Linux, it's just, I'm not going to buy it. No tucks, no bucks, right? Like, no Linux version, no money. It seems like that ship has mostly sailed, for better or worse. There are certainly some problems there. There is some tech right now which doesn't really work properly on the Linux side of things, where certain new games are causing problems. But I think long term, this is probably going to result in the easier path forward for developers, right? I would like proper native Linux games. I think at this point, though, that ship has mostly sailed, and I don't see it coming back to port. But there is another thing. The proprietary drivers, every so often, do drop old hardware. Hardware where, realistically, if you wanted to keep supporting it, it could continue to be supported. But when we're talking about Mesa, when we're talking about RADV, that doesn't have to be the case, and generally isn't the case. The kind of support period you get in the Mesa project is vastly longer than what you see from any of the proprietary drivers. There are cards from 20 years ago which are still getting updates to this day, still having driver improvements, and whilst not many people are running them, they're still supported. You still can keep using them. You're going to have problems because they're older cards and maybe it supports an older standard. But even so, you don't just have to abandon that hardware just because suddenly they decided, oh, well, no more updates anymore. We're just going to pull support entirely. Good luck getting it working. This effort builds directly on the groundwork laid by Faith Ekstrand, who first explored the feasibility of running RADV on Windows and presented her findings at XDC 2024. This talk is 52 and a bit minutes long. We are not going to watch the entire thing here, but it will be linked in the description down below. And if you're curious about how something like this can actually be done, thank you, YouTube, for not updating anything that I'm clicking on. What a great website. If you're curious about how this can actually be done and how drivers actually work in Windows, go give it a look. A central theme of her talk is that since Windows 10, the WDDM2 interface provides a much better foundation for a third-party driver than what came before. It defines a clear model for how a user mode driver, UMD, interacts with the operating system and the kernel mode driver, KMD. However, there is, of course, a significant catch. This is the thing that makes doing this difficult and why, even though this is feasible and work is being done here, it's going to take quite a while, especially if you don't have direct help from AMD to get it to a state that it's good. Many D3D KMT calls can carry private driver data, opaque, vendor-specific blobs whose contents are entirely up to the driver. This means the UMD and KMD remain tightly coupled and that this interface is totally undocumented. Well, it is documented. It is totally documented. Not the documentation that you're going to see, though. It's documented at Microsoft or at AMD. Probably both of them. But you don't get that. To work around this, Faith created the WDDM2 PDD RE tool to log the WDDM2 calls and the private data content for some D3D12 applications, that's DirectX 12 applications. Using this approach, she was able to reverse engineer enough of the private interface, querying adapter info, allocating buffers, creating queues, and submitting commands to get RADV to submit work to the proprietary kernel driver, and ultimately she was even able to get a 3D model displayed on her screen in all its glory. This proved that it was possible. Now, a 3D model that rotates, not exactly very useful, but it's a start. Onwards to the first game. Where Faith's work established that this could be done, this project picked up the thread. The goal was to improve upon it, to make it more flexible, support for different hardware by reducing hard-coded values, more portable, breaking free of WSL with native Windows support, and far more stable, no longer crashing after 2 minutes of testing. We improved command stream handling and synchronization and add support for, among others, sparse bindings, tessellation, and task shaders, and dynamic querying of GPU properties. It is still not conformant with the latest Vulkan standards, even though the success rate has dramatically increased. But the real highlight is being able to run our first game with RADV, Counter-Strike 2. Anyone can try it by switching the renderer with the -Vulkan argument. That can now be played. Now, is it going to be the best Counter-Strike 2 experience? Probably not. Is it going to be a good experience? Probably not. But it will play, and that is very, very important. Now, it does say an average FPS of 162, but that is one picture. FPS doesn't tell the entire story. There's still a matter of stutters and 1% lows and other things like that, which tell a much bigger picture, and that data is not here. Like any other port and or reverse engineering project, it brought some challenges. New generation hardware is oversensitive. We were experimenting on Gen 11 hardware while Faith was working on 10th gen hardware. We weren't able to replicate Faith's results for quite a while due to architecture changes between these two generations. The main problem is that it would hang as soon as you tried to do anything more complicated than clearing a surface to a hard-coded color. Basically, it seems to have a lot of error checking in there, so if you're doing things in a way that it doesn't exactly expect, it just dies. Unfortunately, with no tools to debug such hangs on Windows, this forced us to improve the tools to reduce discrepancies with the proprietary driver as much as possible. We upgraded the reverse engineering utility into a full WDDM2 logging layer, able to analyze any application run with the official Vulkan driver, and added support to dump the command streams, registers, and shader code, basically to get as much information as possible from the driver they know works, and use that as a way to basically say, okay, how do we get our driver to look like that driver? That driver appears to be working, so just try to do that. Compilers are not playing nice. Maester is developed primarily against GCC and Clang. These are the C compilers we use on Linux primarily, and its codebase relies on a number of assumptions that don't stand when compiling with MSVC, the compiler used on Windows. For instance, MSVC doesn't agree with the other compilers on how to handle enums. It can interpret a value as signed and limit them to 32-bit values, which can result in quite surprising behavior. I've heard you liked opaque blocks, so let's put opaque data into your opaque API call, D3D KMT escape. WDDM2 has the possibility of vendor-specific hooks through that method, where the entire content is completely up to the vendor. There is no defined structure, and the only limitation is that it shouldn't replicate something from an existing standardized call. Fortunately for us, it looks like we can safely ignore those for now, as they seem to focus on advanced features I just had a very minor power outage. Thankfully, I have a battery backup, so you got to see that one. Anyway, fortunately for us, it looks like we can safely ignore those for now, as they seem to focus on advanced features such as multi-GPU rendering. Onwards to the future. The biggest open question for making this production ready is the interface to the proprietary kernel driver. Developing our own KMD is not really an option, so we need to communicate with the AMDs. Right now, doing so relies on reverse engineered knowledge of private data structures, which is inherently fragile. It's undocumented. If it changes between architectures, that's a whole new amount of work that needs to be done. It's a bit of a mess. To make matters worse, the UMD and KMD ship together as a match pair with no backward compatibility guarantee, so these structures can change between driver versions with no notice. For RADV to become genuinely stable and maintainable on Windows, we need one of a stable, documented interface to the proprietary kernel mode driver, or a shim library that mediates communication with the KMD through the private data channel, giving us a stable surface to build against even as the underlying blobs evolve. Basically, they kinda need AMD to at least sign off on it, if not get involved at least a little bit on the Windows side of things as well. There is also significant work remaining on presentation. While Jess Natalie did some work on WSI for Windows in the context of the Dozen driver, RADV currently only works with the slower CPU path for presentation. More work is needed to enable the use of DXGI swap chains to improve performance, but that requires being able to import an image from D3, D12, more opaque metadata, hurrah! Even more work would be required to achieve zero-copy swaps, the pinnacle of graphics pipelines. It could potentially lead to a 3x performance gain for applications that are not GPU bound. Accomplishing that last step would also require direct involvement from AMD and probably Microsoft, as there are some limitations related to image sharing. There are precedents to that kind of quality of life improvements for open source projects, so there is hope. This is still a long while away from actually being good and actually being something that if you're on Windows, you might want to run. However, it needs to start somewhere. And people said you would never get Linux running on the Apple Silicon. People said you'd never be able to make open NVIDIA drivers. People said a lot of different things that are just not possible to do. And people make it happen because somebody out there is dedicated, and in this case, there is money to make it happen. So, whilst this is still a long time away, I'm excited for it. And I hope it goes well. And in the long run, it's just going to make the Mesa project as a whole considerably better. So, let me know your thoughts down below. Is this something you would go and use if you're on the Windows side? Obviously, when it actually gets good and somewhat usable. Let me know. So, if you like the video, go like the video, go subscribe as well, go hype if you're on mobile, and if you want to become one of these amazing people over here, check out the Patreon Scribes Daily Bearer Pay linked in the description down below. That's going to be it for me, and radical.